Hello friends, I am Saroj Vishwas, gold medalist, first rank holder of 1994 batch in engineering stream of all the colleges affiliated to University of Mysore during that period. A BE in civil engineering from National Institute of Engineering Mysore, a MTech in structural engineering from Indian Institute of Technology, Delhi, that is IIT Delhi, a Sun certified Java programmer, Sun Microsystem USA. I have more than 25 years of professional experience in designing building structures and allied subsidiaries. I invite you all to learn with me how to design building structures using commercially available structural softwares with the help of some manual computation as and when needed. In last sections, we have learned to define the primary load cases, that is the gravity load cases, the seismic load cases and the wind load cases, and how to apply those primary loads to STAAD Pro model. Now in these sections, we will learn the load combinations, that is how to define the load combinations involving all the primary loads that will be acting on the structure and how to apply this load combination in a STAAD Pro model. See, IS 800-2007 in table 4 this gives the partial safety factor for load combination of limit state of strength and limit state of serviceability. Then if you go to IS 1893-2016, in IS 1893-2016, clause 6.3.3.1, 6.3.3.3 and 6.3.3.4 defines the load combinations that is to be considered while considering the seismic load cases. Now 6.3.2.1 said that when the lateral load resisting elements are oriented along two mutually orthogonal horizontal direction, a structure shall be designed for effective due to full design earthquake load in one horizontal direction at a time and not in both directions simultaneously. So if there is the lateral load resisting system has frames which are not orthogonal to each other, so maybe the one frame is in at certain angle to the other lateral resisting load frame, then we may have to consider 30% of earthquake load or seismic load from other direction as well. Lateral load resisting element means those frames or in the structures which are actually designated to resist the earthquake load or the wind load, that is the load that are applied laterally to the structure. So in our case, our structure do not have any or frame that is not orthogonal to each other. Both of the lateral load resisting frame, that is the moment frame as well as concentric breast frame, they are at 90 degree to each other. So we can strike out certain cases from these load combinations. So we can strike out this one, this one, this one, this one, this one, and this one. Now there is another clause which says that when the earthquake effect due to vertical earthquake shaking shall be considered when any of these following condition apply. For building structure, this 6.3.3.1a is most important. It says that when the structure is located in seismic zone 4 or 5. So we need to consider this one, these 6 cases for our building. Now see, In the code, this ELZ is in vertical direction, but for STAAD Pro, STAAD, it is ELY, which is in vertical direction. That is, Y direction is in vertical direction, and our X and Z directions are horizontal directions, X and Z. Now let us start defining the load combinations using the STAAD Pro graphical user interface. Let us go to General. So in General, let us go to Load. We have this load cases detail. Select load cases detail, then add, select, define load combinations. So we will first define load case 51, as we have already discussed that we will maintain certain gap in the serial number of the load combinations. So this will be our 1.5 DL plus 1.5 LL. This will be the case 1.5 1.5. So we shall define 1.5 DL plus 1.5 LL. Now, which is the load combination? Let us now our wall loads are also dead loads, so let us add this 1.5 wall. We have wall as the wall load as dead load. So our factor is 1.5. Here we have defined 1.5. Now let us select dead flow load to right, and wall load to right, then live load to right. Add. Now see, the load has been added here. Now we will define the load combination involving dynamic load cases, that is response spectrum load cases. So again, go to load cases, add, define load combination. Now we'll take this first load as 101. So this will be 1.2 DL plus 1.2 wall plus 1.2 LL plus 1.2 response QX in X positive direction. So our factor is 1.2. So let us take 1.2 dead flow load, then 1.2 wall load, then 1.2 live load, then lay all load case number 5 is response spectrum in positive X direction. So let us take this, add, close. Now this load combination is added here. Now let us open the STAAD Pro editor, scroll down to load case 101. Now we'll define other 3 cases using this load combination 101. Let us copy it, paste it 3 times below. 1, 2, 3. Now let us change the number of load combinations, numbers of the load combinations: 102, 103, 104. Now our first case will be positive X direction, the second case will be positive negative X direction. So we'll make the factor for load case 5 as minus 1.2. Okay, then third case will be positive Z direction. In response spectrum in Z direction is load case 6. So we'll make this 5 as 6. Then The fourth one is negative Z direction. Let us change this negative Z direction. Then again the load case in Z direction is load case 6 and it is in negative direction. So let us make this factor as 1.2. So this is the way how we can speed up the STAAD Pro modeling and definition of load combination. If you keep on using the graphical user interface, the modeling process becomes slow. So we should actually use both STAAD Pro editor as well as the graphical user interface to speed up the modeling in STAAD Pro. Now let us see how we have got this 1.2 factor. See, these are the load combinations involving 1.2 factor, where all the factors are 1.2. Similarly, we have to define load cases with this factor as well, this factor as well, and with 1.9 DL. DL will include both floor dead load FDL plus wall dead load. After that, we have to define the load combination involving the load combination given is IS 1893/2016. Already we have already told we do not require this load in this direction, and this load will be there because vertical direction is to be considered in zone 4. Now note that in IS 1893 ELZ is the vertical direction, but for STAAD Pro our vertical direction is in Y direction. So in STAAD Pro the load involving in vertical direction shall be RES QX positive Y and negative. Similarly, RES QX negative Y. Next, you have to define the wind load cases involving all these factors one by one. After these will complete, these together will complete the limit state of strength load combinations. After that, we need to go to serviceability load combinations. These are the serviceability load combinations with DL and LL as one factor, then DL as 1. This DL will include both floor dead load and wall load, LL as 0.2, WL or EL as 0.8, and again only in case of dead load without live load, both the lateral load and the dead load will be having a factor of 1. I have already defined these load combinations in the template. If you go through the template, you will be able to understand easily how these load combinations are to be formed. So if you can form the load combinations with any code like IS 800/2007 and IS 1893/2016, you will be able to define the load combination required for any other international codes. Open the STAAD Pro editor where I have already defined the various load combinations for you. We have these load combinations 51, 1.5 DL, 1.5 wall plus 1.5 LL. Then we have dynamic seismic load combinations, that is involving response factor method. 101 to 104 is 1 with factor 0.9 and 1.5. these load combinations. Then 107 to 110 is these load combinations. Then 113 these combinations. In similar way, I have defined the load combinations involving IS 1893-2016 requirements. If you can see this in vertical positive x direction, negative x directions, it has been taken positive x directions, negative x. We have this positive y direction, the negative y direction with combined with x direction, then negative y direction, positive y direction, common this z direction. Similarly for other cases as well. Then we have defined the same load combinations with static load cases. In static load cases, obviously we do not have this load in y directions. So it has not been implemented in STAAD Pro V8i E-Connect edition. Probably they have included this, but we have already included in dynamic analysis. So our this will suffice the requirement for the design. Then comes the load combinations involving wind load, 0 degree, 180 degree, 0 degree, positive CPI, negative CPI, positives. So then comes the serviceability load cases involving these combinations. Note that I have used response spectrum for estimation of serviceability. Analysis. This is because for strength design, the base shear has to be scaled up to match up. The dynamic base shear has to be matched up with static base shear. But for displacement estimate, we do not require to scale up the base shear, and we can check the permissible deflection with respect to the displacement estimation obtained from the dynamic analysis with a scale factor 1. For deflection estimation, dynamic analysis with a scale factor 1 suffice, because base shears are scaled up for the dynamic base shears are scaled up to match up with static base shear, because the non-structural member in the building actually increases the stiffness of the building. So more seismic loads are generated because of more stiffness. Now again, on the other hand, because of the more stiffness, the lateral deflection will reduce. So the dynamic analysis with VR frame is enough for estimation of lateral displacement and compare it with permissible deflection limit in lateral direction. These are the load cases, load combinations involving wind load cases, positive CPI, negative CPI. Then I have already added one more set of load combinations in the template, which is usually required for foundation design. For a steel designer, it is not required, but those who are interested in RCC design, they will require this combination to design the RCC foundation supporting the steel structure. With this, the load combinations definition of the load combination completes. Next, we have to define the load envelope involving the strength and the load envelope involving the serviceability cases. The strength cases, strength group will require for the design of the member, and the serviceability group will be required for the estimation of lateral deflection as well as the vertical deflection. Having defined the load cases, we'll now we'll save the STAAD Pro editor and define the load envelopes. So let us go to the load envelopes. Add. Now first we'll add strength load cases. Our strength load cases is from 51 to 338, which includes all the limit state load factors. So add. Then we'll define serviceable load cases. These are from load number 1000 onwards, which contain the factors of serviceability defined in IS 800 2007. So we have now one envelope for type strength and another envelope for type serviceability. So we save this and saved. With this, we end the section on definition and application of load combination. Before I end up the section 1 load combination, I would like to explain you what are not orthogonal lateral load resisting frame and non-orthogonal lateral load resisting frame. See, this is the model which we have been modeling. Now we have one set of lateral load resisting in the form of concentric brace, one set of lateral load resisting frame in the form of concentric braid, and another set of lateral load resisting frame in the form of woven frame. Now if you see, these frames are at 90 degrees to each other. So for this building, the lateral load resisting frames are orthogonal to each other. Now come to this building. Now see, in the 3D view as well as on the plan, this frame is at an angle to this frame. So if you see that, it is something like that. It is something like this. So obviously this angle is less than 90 degree. It is not orthogonal. So for these buildings, we have to consider 30% of seismic load from other direction. For example, if seismic load, the main seismic load is in X direction, so we will have to have Ex plus 0.3 Ez for STAAD Pro, obviously. Now, in case of zone 4 with load combination factor, it will become something like this: 1.2. For dead load live load cases, 1.2 DL plus LL plus EQX plus 0.3 EQZ plus 0.3 QY. So the actual load combination we'll be getting is 1.2 DL plus 1.2 LL plus 0.36, sorry. So ultimately we'll get this combination 1.2 DL, 1.2 LL, then 1.2 EQX plus 1.36 EQZ plus 0.36 EQY. So this will be the load combination that will be required for a building in which the lateral load resisting frames are non-orthogonal to each other, and it lies in seismic zone 4 or above. In next section, we will try to apply different design parameters to the STAAD Pro model, and we'll perform design of the sections. We'll try to optimize it, and then we'll match the base shear. See you with the next section.